This physics problem involves a boat and a raft on a flowing river. Let's read the problem statement. A motorboat going downstream overtook a raft at point A. 60 minutes later, it turned back, and after some time, passed the raft again at a distance of 6.0 kilometers from point A. Find the flow velocity of the river, assuming the duty of the engine to be constant. First, let's clarify what constant duty of the engine means. This means that the boat's speed relative to the water stays constant. In other words, the boat maintains the same speed through still water. Let's define the variables we'll use to solve this problem. We'll denote the flow speed of the river as u. The boat's speed in still water is v. The time after which the boat turns around is 60 minutes, or 1 hour. And the distance from point A where the boat meets the raft again is 6 kilometers. Let's visualize the scenario. We have a river flowing from left to right at speed u. At time 0, the boat overtakes the raft at point A. The raft simply drifts with the river current at speed u. The boat travels downstream at speed v plus u, which is the boat's speed through still water plus the river's flow speed. After 60 minutes, the boat turns around. Let's calculate how far the boat has traveled downstream in this time. The boat's downstream speed is v plus u, and the time is 1 hour. So the distance traveled downstream is v plus u times 1, which equals v plus u kilometers. Let's call this turning point B. Now the boat travels upstream, against the current, at a speed of v minus u. Meanwhile, the raft continues to drift downstream at speed u. Eventually, they meet at a point 6 kilometers downstream from point A. Let's call this meeting point C. Let's call the time for the upstream journey t sub 2. During the total time of t sub 1 plus t sub 2, the raft has drifted a distance of 6 kilometers. Since the raft moves at speed u, we can write u times the quantity t sub 1 plus t sub 2 equals 6. Solving for t sub 2, we get t sub 2 equals 6 divided by u, minus 1. Now, let's consider the boat's upstream journey. The boat travels from point B to point C at a speed of v minus u. The distance from B to C is the distance from A to B minus the distance from A to C, which is v plus u minus 6. So, the time it takes for the boat to travel from B to C is this distance divided by the boat's upstream speed. So, the quantity v plus u minus 6 divided by v minus u equals t sub 2. We have two expressions for t sub 2. Let's set them equal to each other and solve for u. 6 divided by u minus 1 equals v plus u minus 6 divided by v minus u. Let's cross-multiply to eliminate the fractions. We get the quantity v minus u times the quantity 6 divided by u minus 1 equals v plus u minus 6. Let's expand the left side of the equation. We get 6v divided by u minus v minus 6u divided by u plus u. Simplifying, we have 6v divided by u minus v minus 6 plus u, which equals v plus u minus 6. Canceling out the common terms, we get 6v divided by u minus 2v equals 0. Factoring out v, we get v times 6 divided by u minus 2 equals 0. Since v is not 0, we can write 6 divided by u equals 2. Solving for u, we get u equals 3. So the flow velocity of the river is 3 kilometers per hour. Therefore, the flow velocity of the river is 3 kilometers per hour. Let's verify this answer by checking our equations. If u equals 3, and assuming a reasonable value for v, say 6 kilometers per hour, then t sub 2 would be 1 hour. This means the boat meets the raft 2 hours after the initial encounter, at a distance of 6 kilometers from point A. All our conditions are satisfied. To summarize our solution, we identified that the boat and raft meet at a point 6 kilometers downstream from their initial meeting point. The boat traveled downstream for 1 hour, then turned around and traveled upstream until meeting the raft again. By setting up equations for the raft's motion and the boat's motion, and then solving them simultaneously, we determined that the river flows at a speed of 3 kilometers per hour.